Alright, in this video we're going to find the interval of convergence for this infinite series. So we use the ratio test as usual. Okay, so the n plus first term looks like this. The only thing that needs the absolute values are the x plus 3. Okay, so all that was just the n plus first term. And then to divide by the nth term is the same as multiplying by the reciprocal. So I'm going to write this. And then we'll simplify. All right, so that was this. So the reciprocal of that. All right, and so let's see, what can we clean up here? That leaves behind a 5 in the bottom. I have one more copy of an absolute value of x plus 3. And so that's it for like the cleanup part. So I think, so this becomes absolute value of x plus 3. And I have an n plus 1 on the top. And on the bottom, I have a 5 and an n. Okay, so now we take the limit as n goes to infinity of this expression. So I'm kind of separating it in a way I think that'll make the limit easier to compute. So one thing I tell my students, anything that doesn't have an n in it, you could always take out. Let me just point that out here. That way you can focus just on the limit. Okay, and so now this, this expression here, that limit is equal to 1. So it becomes absolute value of x plus 3 divided by 5 times 1. All right, and then, so that's an expression, and by the ratio test, we need, I'll just say we want all the x values that make this true. Sorry, this should be a 3. Okay, so multiplying through by 5. Okay, let's turn this into a double inequality here. And then add 3, minus 3 rather. All right, so far that could be my interval of convergence. The one thing that the College Board expects you to do and that you're supposed to do at this point is, so the ratio test doesn't tell you what happens at -8 and 2, the endpoints. So we have to check endpoints. Okay, so for example, when x is equal to -8, then that series above looks like this. So it's n, so -8 plus 3 is -5 to the n. Okay, now this can be rewritten if you'd like as, so I'll explain in a minute if you're not clear why this becomes -1 to the n times n. As a little aside, I'll just point that out. So the reason that's the case is because, remember, -5 to the n is the same as -1 to the n times 5 to the n, because this is -1 times 5 to the n. But that means the 5 to the n's cancel down below. Okay, so what do you know about this series here? Well, first of all, it's alternating. So what you typically do if you're looking at an alternating series is you see if it converges absolutely. So let me just kind of note that. To converge absolutely would be to analyze the absolute value of the terms. But this clearly diverges, right? This is just, 0 plus 1 plus 2 plus 3. So it does not converge absolutely. And to converge conditionally, you would just need that this term here, is that decreasing to 0? And the answer is, of course, not. It's growing. Okay, so -8 doesn't work as an endpoint. Let's try the other endpoint. Let's try 2. So when x equals 2, okay, and again, don't forget, I'm plugging in right for this x up here. So 2 plus 3, and that's so it's n times 2 plus 3 is 5 to the n divided by 5 to the n, right? That's gone, and I just get this. Okay, but that clearly diverges because it doesn't pass the nth term test. It's not an alternating series, so we don't have to ask like absolute or conditional. Okay, so this diverges, and there's nothing to say that this is none of the endpoints worked, or neither of the endpoints worked, and so this here is my interval of convergence. And we are done. That's all they needed.